Static types and static variables. What are static types? Static types refer to the use of explicit type declarations in GDScript, allowing the language to enforce type constraints at compile time rather than at runtime. Let's take a look. Can you tell which is a static type? If you guessed this, then you'd be correct. In static typing, variables have a fixed type, defined explicitly in the code. Dynamic typing, variables can hold any type of value, and type check happens only at runtime. Godot does support mixed typing, allowing you to combine both static and dynamic typing in the same script. If you don't declare a type, the variable remains dynamic. I like to use static types because static types make your code scripts more robust and reliable, especially in a large or complex project. But that is just my opinion. Make static type by declaring the type. In this example, we use :int equal 1. It also works like this by declaring the type for the variable. We can declare ints, floats, strings, etc. Some of the benefits of static typing. Error prevention. It's easy to catch type-related bugs early in development, before running the game. Code readability. Knowing variable types at a glance makes the code easier to understand and maintain. Auto-completion and hints. The Godot editor provides better code suggestions and error detection for static type scripts. Performance. Static type code is compiled into more efficient bytecode, improving the game's performance. Now you know what are static types. Let's take a look at a static variable. Let's make this a simple game where the player collects cherries by colliding with them and updates an on-screen cherry counter. Let's set up an example level. I used a canvas layer with a label node to show how many cherries the player picked up, an area 2D node for the cherries, and a character body 2D node for the player. I also used a tile map layer for the ground. Now let's take a look at how I created the cherry pickup. I used an area 2D node, attached a script, and in the inspector connected an onBody entered signal to the script. This defines a globally accessible class named pickup. With this declaration, you can refer to this class anywhere in your project by the name pickup, without needing to load or preload the script file. The static keyword declares that the variable cherries collected belong to the class itself, not to any particular instance of the class. This means that all instances of the pickup class share the same cherries collected variable. If one instance changes its value, that change is reflected across all other instances and references to the class. I will get a reference to the cherry text label by using its unique name. Then create an onBody entered signal. Check if the body entered is the player, and then add 1 to the cherries collected. Update the cherry label text, and then call queueFree on the cherry to remove it from the scene. Why does this work? As I mentioned before, the static keyword declares the variable cherries collected belongs to the class itself, not any particular instance of the class. You can use this to track the total number of cherries collected in a game, no matter how many instances of the pickup objects there are present. This setup is particularly useful for tracking global game data like scores, health, or collected items. And there you have it, an easy way to use static variables to keep track of data in your game. Thanks for watching. We discussed a lot today, core mechanics and no gimmicks. I do hope this video was helpful. If you liked the video, give it a like, subscribe, and turn on notifications so you know when I upload another video. And speaking of my other videos, why not check out another one of these videos here? This has been Diragu Games.